group have chosen a dataset about in-vehicle coupon recommendation which was obtained from UCI Machine Learning Repository website. The survey analyzes various driving circumstances such as the destination, present time, weather, passenger, and so forth before asking the driver whether he agrees to take the coupon or not based on demographic and contextual factors. The objective is to determine the customer's choice on whether or not to accept a restaurant coupon offered by an in-vehicle recommendation system. The dataset that we used contained 12,684 instances and 26 attributes. It consists of a mixture of numerical and nominal data with missing values. These are the list of attributes from our dataset, which ranges from nominal and numerical data. As you can see, the numerical data has 8 attributes, which are temperature, has children, 2 coupons, EQ 5 minutes, 15 minutes, 25 minutes, direction same, direction opposite, and Y, which indicate on whether or not the driver will accept the coupon based on in-vehicle recommendation system. And the rest of attributes are all nominal.
Next, for A2 is the data cleaning. In this, we have 4 parts, which is to identify the numeric and nominal attribute, how to remove missing value, noisy data, and outliers and extreme value detection. So, for part 1, firstly, we open Explorer, then process step will appear. Then, we can see as the picture when we found out the type of attribute. And then, there are 2 types of attribute that was found in our data set, which is nominal attribute and numeric attribute. The numeric attribute is quantitative type since it can measure the quantity that will show the data in type of integer or real value. While for the nominal attribute is qualitative type since it cannot be measured, but it also refers as categorical attribute and it represents the value in category, code, or state type. In the numeric attribute, we can find out the details such as the maximum, minimum, mean, and standard deviation for each attribute in our dataset. So, this is the list of numeric attribute in our dataset. While in the nominal attribute, we can get the label and count that can be seen in the picture. So, this is the list of nominal attribute in our dataset. So, for the part 2, missing value. Usually, in the dataset, missing value can occur or sometimes it doesn't. Missing value means the value is missing or no value appear due to it was lost or forgotten by the dataset. However, missing value can be replaced with the minimum, maximum, or average value for that attribute. Replace missing value also can be applied with V0. So, in this picture, you will see where is the place of missing value for car attribute. So, this is the list of missing value in our attribute. So, we are using the filter in the WEKA to remove the missing value. By choosing filter under unsupervised, then click attribute, then take the replace missing value, then apply it. Then, we get the missing value in our attribute become 0. Part 3 is noisy data. Noisy data is meaningless data or corrupt data. This means the dataset that has been received or stored, but it cannot read or used by the program. That is why it referred as noisy. If that kind of data is not being removed, it can lead to a false sense of accuracy or else can cause the wrong conclusion. So, we doesn't apply the noisy data since our data is useful and no damage or error occur. So, the method to detect and remove noisy data by using k-fold validation, clustering, and regression. So, for the part 4 is to detect outliers and extreme value. In our dataset, we do the outliers to increase the variability of our data that can decrease the statistical power. We start by looking at the viewer the attribute until the last attribute before run the interquartile range for outliers. This is because after run the interquartile filter, it can appear at the end of the attribute. After applying the interquartile range filter, the outliers and extreme value will be appear at the end of the attribute. The extreme value show the yes and no label, where when the yes is appear, it needs to be remove the instances. That's how to apply the filter. We choose the remove value and left click, so there will be a pair of box. Then change the attribute index to 28, then apply it. So we have done in data cleaning and save it as file clean.
Hi, my name is Aina Nadira and I will present about A3 data preparation, which also be named as data transformation, that includes normalization, discretization, and attribute construction. On the first slide of normalization, data normalization main purpose is to decrease or even remove redundant data. It is an important part of data mining that requires altering the data, which is converting the original data into a format that enables for efficient data processing. There are three filters that could be applied, which is min-max normalization, z-score normalization, or decimal normalization. For our dataset, we use min-max normalization. To apply the normalization, you have to open Weka and click Pre-Process tab on the top of left, then click the filter and the menu box will appear. After that, click Unsupervised, choose an attribute, choose Normalize, click OK, then click Apply. As we can see from the slide, our group picked the numeric attributes temperature, which required for normalization. The data of temperature before normalization has statistic of minimum value of 30, maximum value 80, mean value 64.17, and standard deviation value of 18.755. After the normalization, the value of minimum becomes 0, maximum value becomes 2, mean is 1.367, and standard deviation is 0.75. After normalization, the data has undergoes discretization. Discretization is the process of transforming numeric attributes to nominal. It is essential in order to use a classification method that can handle numeric attributes, or to produce better results, or to produce a more comprehensible model such as a simple decision tree. For discretization, we change one numeric attribute into nominal, and we change the bins into 3 for the attributes. In this second step of data transformation, we also use attributes temperature to be discretized. For the step of discretization, we open Weka and click Pre-Process on the top of left, then click Filter, choose Unsupervised, choose Attributes, and then choose Discretize, and then you can apply. For the result of before and after, the data has become a nominal attribute with 3 number of label, also shows the count and weight for each label. Next, the label is named with random words. Therefore, it is need to be changed. To change the level of temperature, it needs to be done using the Microsoft Excel. The step for the labeling is, first, you have to save the dataset in CSV.file and open in Excel. Second, press Find and select in the editing section. Then, find the class label and replace with a new name. Then, save file and open in ARFF file. The data after labeling will show the new name of temperature, which consists of middle, high, and low. Lastly, for the attribute construction, we did not use this step in our data as we find it is unnecessary for our data. However, to explain more further about attribute construction is adding a nominal and a numeric attribute to your data set identified by the file name given as first parameter. It occurs when we adding an attribute which representing either sum or subtraction of two other ones. If attribute construction is added, first go to Filter, then Unsupervised, then go to Attribute, add expression, select the description, then change name to any name that desired, then go to Expression field with mathematical expression involves subtraction or addition of two other attributes, then save. Lastly, click Apply.
Next is model development and evaluation. In this task, we use classification method for the model development. Here are the steps and results after we apply the classification to the full dataset and reduce dataset. First, on the full dataset, we use the cross-validation K10, and you can see from the procedure at the top. So the accuracy we got is 35.2941%. Next, for the K20, the accuracy is 35.2231%. Next is percentage split, 70%. As you can see the procedure on the top, we got 36.1736%. Next is for percentage 80%. We got 36.6864%. Next, on the tree visualizer, on full dataset, you can see the procedure on the top here. So this is the tree, and the number of leaves is 31. The size of the tree is 40. Next, to the reduced dataset, the accuracy we got for the cross-validation K10 is 60.4024%. The K20, the accuracy we got is 60.3077%. Next is the percentage split, 70%. The accuracy we got is 59.645%. For the percentage split, 80%. The accuracy we got is 59.7633%. Next is the reduced dataset tree visualizer. You can see the procedure at the top, and we can see the number of leaves is 17 and the size of tree is 22. It's been reduced from the full dataset. Next is F4, the data preparation reduction. As you can see from the procedure on the top, we choose Infogain attribute and we select ranker. We got 5 attributes: time, point, outlier, extreme value, and acceptance. So this is the data set before we reduce. The attribute is 7, time, coupon, coffee house, carry away, outlier, extreme value, and acceptance. After reduction, we remove coffee house and carry away Mecca, and the attribute we got is only 5. So this is the first 20 rows of the reduced dataset. So as you can see, this is the accuracy comparison between full dataset and reduced dataset on cross validation for K10, K20, percentage split 70% and percentage split 80%.